Hi guys, and welcome along to part 4 of making this slightly larger than miniature hit and miss engine, stationary engine. We'll go through, I'm going to try and make the conrod. Also some gears have come. I've been a bit of a cheapskate really, because we're going to try and cut some gears, but unfortunately all the gear cutters I've got are all way too big, the profile on them, so I'd have had to buy one, and that would have cost more than what I paid for these. They're on cheap, the brass and the nice, the mesh well. I've got a 40 and an 80, 40 for primary obviously, 80 for the secondary, but we'll go through and I'll explain what I'm going to do with them. And in fact that might be the first part you'll see, is working on the lathe, slimming them down because they're too thick. Okay guys, but basically it's these gears, which is not a lot of it, but just a bit, and then making the conrod. I hope you find it interesting. Thank you. The thickness of these gears are I think 6mm. Yeah, 6mm, and I need to get them down to maybe 3 or even 2.5, maybe 2.5 and a bus there. But every millimeters is of essence in these measurements I'm doing, and I've got to try and get clearance for on this particular gear, a camshaft. I was going to machine the camshaft from that, but I'm not so sure. I might that if I did that, then there's something like a 4.5 degrees it could be out. If that machine on there solid, because of how many teeth they are on here, 80 and 360 degree wheel, between every tooth will be 4.5 degrees of crank travel, which is too much. You know, if I wanted 1 degree before top dead centre or 1 degree after top dead centre, I won't be able to achieve it with this. I won't be able to do it. You know, I'd move one tooth and then the next tooth, that would be 4.5 degrees, which is too much. So I'm thinking of cutting that off, trimming this gear down as well, like this one, but cutting that off and making a camshaft that I can adjust, and when it's final I can pin it or whatever. So I'm going to start shaving a bit off this. No, I think that'll do. Right, what do I need to do now? Do the other one. Yeah, and then 4 jaws going to have to go in. Slight difference. Lovely. Alright, I need wire brush through them. Yeah, I'm struggling to mesh now. Need to wire brush them up, but yeah. So my next thing is, do I part that off? The only worrying thing is, if I part that off, is it's only now 3mm wide. Is that going to be enough for support, or is it going to wobble? Whereas with that on a Boss, it won't wobble. But 3mm wide, it's going to introduce wobble, I'm sure it is. That one won't, because that's pinned onto the shaft. That one's going to be free running in a piece of steel bar. So maybe I need to think about that, whether I machine it. No. I was going to machine just a right little bit of chamfer off, still leaving grub screws. I won't need grub screws, because that's going to be free running. I need to think about that. Need a reamer. Right, so once the crankshaft pushed back together, that crank pin disappears obviously into there. That's going to go on there, but right up to that shoulder. Sorry, it's not going up to that shoulder, it's going up to, with obviously a shim, that bearing. Yeah, good fit, great, I'm happy with that. So we've got the piece of brass in the milling machine for the conrod. The conrod wants to be 9.5 millimeters at the widest, which is between the crankshaft two halves for the big end. That wants to be down at 9.5. I'm going to allow probably 0.1 at each side just for clearance. So I need to take about 3.3 millimeters off this. I think it's 12.7. It's ½ inch, which is 12.7. Yeah, so it's 12.7 millimeters thick. Before I start shaping it and everything, I need to take it down to its end thickness. So we're going to use the big 63mm 6 insert cutter, which makes a nice clean job. So I want to try and keep it as clean as I can as I'm doing it. So just going to shave that down. That'll do it. Right, so where are we up to? Well, I made a drawing of what I thought my conrod would want to look like. That's the little end. This is the big end. I was going to put some shape into it and just shallow tap and put a couple of probably black Allen screws into there to make it look like it was clamped in two halves, when in actual fact it won't be, because we're using a needle roller bearing, so we don't need that. This piece of brass was ½ inch thick, 1 inch wide and 6 point something long. I've chopped a piece off the end. I did mark out this conrod to be longer, but to be honest with you, it looked a bit lanky. It didn't look right, and I thought that does, or to me it does. So basically I've drilled the centre hole for the little end and the centre hole for the big end, they're exactly 5 inches apart. That's going to be the length of the conrod centres, 5 inch. Obviously I've done that, that's M6, 6mm, for a reason, obviously, for going on things like the rotary table and, you know, shaping it and that. Sometimes they can be handy to be there. So I've put them in now, and then I've got to start and think about, I've narrowed it down on the milling machine, as you've seen, and it's now 9.5. It's actually a right little bit fatter at this end than this end, and that wasn't meant to be. So I did check, there were no debris in there. I don't know how I've done it, but something. I need to probably take that vice off and have a look underneath it. I wonder if there's a bit of swarf got under there. I don't know. But anyway, it doesn't matter, because this end wants to be narrowed down to 8mm wide eventually. And this end wants to be 9.5 plus, 9.5 minus a little bit of slack, so that it doesn't nip when I press the flywheels back together. It doesn't nip. Right, that's the plan. This shape here, if you can see it, this is going to be a relief. I showed it to a friend and he thought, oh, you're going to drill all the conrod away there. And I says, no, I'm not going to remove all that material. I'm just going to put a shallow, probably, I've got a small ball nose there. I've got quite a few different ball noses out to go through it, so that I can, well, obviously that end, it's going to be that little one, and then come up it and round and back down, then take the centre out. But I'm only talking about, oh, 0.5 millimetre, 1 at the most to remove. I don't want to remove a lot, because obviously both sides will be the same. Don't want to make it weak or anything like that. Yeah, this end here is going to be sort of square. I'm not going around there. I'm going to sort of square this off a bit like a car conrod would be, to put the 2 bolts in, just to make it look authentic, really. So I think my next thing to do is I might re-blow this, because it's a bit scratch off. It wants re-blowing, so that I can see my marks better. When I might think there's anything else I could show you. I got the gears right. I'm still working like mad on my brain about a governor. I don't particularly like the governor that goes on the outside of the flywheel, the one that expands on the outside. I mean, I've looked at, I've got to make a boss to fit in here, a brass boss, and somehow lock it in so that it can't ever come out. And I'm thinking of machining all that away so it's dead flat, and then working on the boss that's sticking out, leave quite a bit of material, and see about making some sort of governor that fits there with the weights on the inside or whatever. Don't know, undecided. We'll get there. Hi guys, just thought I'd show you a few little items that's come through the post. And I did say that I'm going to try and build this hit and miss engine as cheaply as I could, and already it's risen to over £100. Although I must admit, I've been looking online, and for one of the size that I'm building, the smallest, the cheapest kit I can find is over £650, and that's in America. Which means there'll be huge import duties and VAT and various other charges that I would think would take it to over £1,000. I've seen 2 of the similar size. No, that's wrong. My flywheels are what, 5.5, did I say, inches diameter, and let me just check. I know you're not in video. Yeah, the 5 inches are my flywheels, and I think the one I saw there was 7.5, so it was a bit bigger, and it was second hand for sale. It had been built by somebody in America, and it was $3,500. Okay, so what's come? The spark plug. got my little spark plug. Now that don't look a bad size in fact, but if you actually rotate it, it's 1/4 by 32. Let's put it into perspective. That's a car spark plug. That is dinky. I just thought I'd show you it because it is so dinky, and I'm going to put it back in its little protective box. It came in a little tube. Come in that little plastic tube, and I'm hoping to use that as an oil drip feeder for the cylinder liner. Make something in brass, and that'd be the tube, I'm hoping. Right, so what else we got? You're not going to believe this. I mean, you can relate to this. They're caged ball races, and the outside diameter of that cage is 6mm, and the screw hole in the middle is 2mm, and that is a caged ball race. How do they make them? I don't know. £2 something it costs for those. I bought two different, what I'm going to use for little ends. That's 10mm wide, and that one's 8, and I do think I'll be using the 8. So that's 8mm outside, it's 8mm wide, and it's got a 5mm bore through the middle. So a silver steel pin, 5mm, will go through the middle. Probably lock it to the piston with two little grub screws, possibly. There'd have to be something like M2 or M3 to grab a 5mm bar. And that'll be little end, so we'll have needle roll a big end, needle roll a small end. So technically, as long as this thing's tough enough, it should be able to run all day long. Okay, I just thought I'd show that what'd come. I did order some other little bits and bats, which I will show. They were dirt cheap, just El Cheapo, Chinese import stuff. A box of, they're called E-clips, of those. And there's all different sizes, from dinky little ones right up. I think the smallest is 1mm. So, because I mean, I'm going to make these valves using that, which is 2 point something millimeters for my valve stems. 2.5. So that's 2.5mm. So I'll have some E-clips there that'll fit on the top as spring collet retainers, will they be called. And then I bought this pack of larger ones, which is, I can zoom back out now. I only zoomed in to sort of show the size of that spark plug. Yeah, so we've got those proper circlips, and it, I mean, again, I think the box was something like £4, but there's tons and tons in, from dinky ones, very small ones, right up, well, smallest is 3mm, right up to 32. I've always wanted some circlips, and always, you know, looked for them and never found them, and I'll only probably use 2 or 3 on there, holding maybe timing gear onto the shaft and stuff like that. But it's something for the workshop. That's not for the project as such, apart from nicking a couple of little clips out of there. The rest of it will be going in the cupboard for stock as such. Put them over there. The other thing I had to buy, another default thing, was right, I were using my milling machine, and I was winding the x-axis by hand back to a start point, and I heard a twang, and when you heard a twang you go silent and listen for something landing, and I did, and I heard something ping over to my left on the floor, and I searched for ages, and eventually I found it. Now, where did I put it? What I found with this, and it's a little roller, and I thought, where on earth has that come from? Of course I fitted this, but I'd forgotten all about it. What I'd done is I'd put my limits on for my X-axis drive, some stops, and I'd forgot to remove them and move them back out, and it had hit one of these and smashed that finger off, which is that finger there. So I got a number off it, and I think that's cost me £8 something on eBay. It's my limit switch for my power drive, for my power feed on X with that Mondeo wiper motor video, if you've ever seen it. So I'm going to have to replace that. Nothing to do with this project as such, but another cost I didn't want. Right, so I've set it up so that the line that I need to cut is parallel with the vise. I was going to drill some small holes, but my piece of work isn't wide enough to do that. The little end would have been okay, could have got a 5mm hole in there and a 5mm dowel, but the big end, there's not enough clearance here. I'd have broke through if I'd have put an a 5mm drill bit in there to get my radius for where my big end journal begins. It'd have broke through on that edge. So I've just scribed 2 lines where I know for a fact that I'm not on the radius, I'm before it, and I can pick that up with emery cloth and files when I come to do the radius, so that ain't a problem. So I'm going to work it down now to my line, and then I'm going to flip it over and do the other side exactly the same. The work is just under 10mm in diameter, and this is a 3-flute solid carbide cutter which is in fairly good condition. So that's 10mm, this is 9 point something. I'm hoping I've worked that out right. I've just eyeballed it, and it's sticking over the edge there. I'm not sure if it, oh yeah, I think it is. If it leaves a line, I'll have to dress over it, that's all. Okay, I'll whip that out and have a look at it. Look at all that brass. If Kev were here, he'd be bagging this up. That's Mr. Factotum's workshop. He does some lovely steam engine stuff. And I'll go watch him. Great guy. But he saves all his brass. Takes it to the scrapyard, it must be worth a fortune. Well, I'm quite happy with that, that looks alright, does that? Let's zoom out. Yeah, it's got the desired taper. This is the big end, little end. And then we can do the radius in on the rotary table. Okay guys, so I've done the other side, So they're both being machined now. Obviously there's machining marks in there that'll all have to be taken out. I got my stops set a little bit wrong when I did this one, but that's fine. That's okay, because I've got to radius this round for the big end, that for the small end. There's loads of material left on that, but at this end it's got me curved round. Man did say I was going to try and create two little bolts here as if it had a proper big end cap on, which it won't have. I'm going to do that on the mains as well. Okay, so yeah, that's turned out fine. I didn't go quite down to my lines. I thought it looked better, fatter. As long as it'll fit and rock inside a 1-inch piston. That's my problem, obviously. This can't be too big, otherwise it's going to catch the edge of the piston. But it has only got a total of 32mm of crank throw. It's only 16mm each side, which is not a lot really because of the length of it. So I think it should be okay. Alright, I'll come back when I've done some more. That's it for tonight. Okay guys, thanks for watching. Just putting the two little notches in the bottom of the conrod where I'm going to put the little M whatever size bolts in, just artificial. I don't know whether to just bore that now and that I'm done. I've got another predicament. I haven't got a 17, it wants boring 17mm for the needle roller bearing. Unfortunately, the only thing I've got that's 17mm is a couple of these. They're brand new, never been used. But to be honest with you, that's a bit brutal to go through their way. So I'm wondering of going through smaller and maybe using boring bar in mil. Not adjustable one. Yep, that's the original conrod, 16.99. go. Yep, exactly what I said. Grabbed straight away and dropped out MT2. Where do we go? I think I better run boring bear down. I was suspicious this is what had happened. And it's a brand new drill, I don't want to be backing it off. But it slipped out MT2 taper anyway. No, good idea. Not a good idea. So far it's just knocking the bird off. There you go. Well, it'll fall through now, and it has done. I didn't want that to happen. Right. God, that's going to need some cleaning now. Oh yeah, absolutely superb. That's the crank pin. I can't pull it out because that's ready to push back in again. Once this conrod's done, I can actually put this back together, press it back together. But to my mate, when I'm out landing me, is my edges. M3. Quite a bit more out. One conrod finished. On with the next project, so I'll publish this. We'll just have 2 minutes and then I'll talk about what we've done. Right, so that's the end of part 4. I've quite a lot of video to edit up. I'll do what I did last time and speed some of it up so that it doesn't go on for too long, best I can. So in this part we've made this conrod. I've done a few other little jobs as well, and I think I did show earlier on some stuff that had come, different bearings. Oh, this afternoon it's another £7 something. I've got, that's 5mm drill rod, steel, so that's going to be for my gudgeon pin, little short piece of that, rest of that will be spare maybe, and a piece of 4mm brass rod which is going to be for the push rod from the cam. So those have been done. For rockers and things like that, I think I'm okay. I've got quite a big chunk of brass plate which is fairly thick, 6.5mm. So we're okay for metal now, I think, to do the whole project. Showed you the little spark plug. Next job, what's next? Part 5. I suppose in the scheme of things, really what I should do is I should make the cylinder liner and if I can the piston at the same time. If not, the cylinder liner then the piston, because I want to make cast iron rings for the piston. So yeah, I've got the cast iron, I've got a slug of aluminium for the piston, because I'm doing the piston in aluminium. Some use cast iron. Some of the genuine ones, which I've been watching a lot of videos of in America, some of them are cast iron pistons, some of them have got 5 piston rings on them. Absolutely amazing. And strangely, when the guys rebuild them, I haven't seen one of them yet gap all the rings in different sections. They've just stuffed it in. And I thought, well, that's not right, you need to gap them. I always remember getting a Triumph Tiger 100 off a guy, and he was an engineer and he made a lovely job of it. He'd made all stainless fasteners. It was a lovely bike. I give him £2 for it, I think, or £1,000, might have been £1,000 for it, and it was a lovely thing. And I did some more work on it and put new exhausts on it, one thing and another, but it always burned oil on right hand cylinder, and I could never understand why. And one day I thought, I'm going to pull the barrels off, and when I pulled the barrels off, piston rings were all in a line, the gaps. I re-gapped them. And other thing is with piston rings, you engineering guys will know this, but some of you lads that are just watching that maybe aren't engineering won't know this. You never put piston ring gap at the front of the bore or the back of the bore on its thrust faces. Never. Always stagger them off. You know, third and a third if you can, but not back. You know, move them round. So as long as they're not at the front or the back, you end up with a scored bore, because the piston, when it fires, it thrusts like that. Okay, so I hope you enjoyed this one, which I'm about to edit, and I'm looking forward to doing next one now. The little M3 screws, what I did on the bottom of the conrod, they're only for show. They don't do anything. But yeah, really pleased with that. Thanks for watching, guys. See you next time.